Black holes. Black holes weren't discovered with a telescope. They were discovered with math. In 1783, an English scientist named John Michell proposed a terrifying possibility. What if a star could be so massive that light itself couldn't escape? He called them dark stars. Decades later, Pierre-Simon Laplace suggested something similar. But there was a problem. This wasn't something you could easily prove. It was an idea trapped in theory. Then, in 1915, Albert Einstein published General Relativity, a new description of gravity where mass doesn't simply pull on objects. It bends the very fabric of space and time. And just 1 year later, in 1916, Carl Schwarzschild solved Einstein's equations and uncovered the mathematical blueprint of a black hole. Now the strange part is, black holes were predicted long before we ever saw one. And even today, most people still misunderstand what they really fundamentally are. Most people imagine black holes as cosmic vacuum cleaners, that they just suck everything around them like a drain. But that's one of the biggest misconceptions in science. A black hole isn't a whirlpool. It doesn't reach across the universe, stealing planets and stars. In fact, if you replace the sun with a black hole of the same mass, Earth would continue orbiting like almost the same way. So what is a black hole? Here's the simplest, correct definition. A black hole is a region of space where gravity becomes so intense that the escape velocity exceeds the speed of light. Escape velocity is the speed that you need to leave gravity behind. For Earth, it's about like 11.2 kilometers per second. Fast, but possible. But as something becomes more compact, its gravity increases and the escape velocity rises. If enough mass is compressed into a small enough space, the escape velocity reaches the speed of light. Beyond that point, escape becomes impossible. The boundary where that happens is called the event horizon. Schwarzschild's discovery is one of the most unsettling parts of this story. In 1916, he solved Einstein's equations for the space around a spherical mass and found something hidden inside the math. A critical radius, a point of no return. Today we call it the Schwarzschild radius. It defines the size of the event horizon for a simple, non-rotating black hole. At this radius, the escape velocity equals the speed of light. Inside it, the escape velocity exceeds light. And since nothing can travel faster than light, nothing can come back out. But the event horizon itself isn't a physical surface. It isn't a wall. It's not tangible. It's not something you can touch. It's a boundary in space-time. Outside of it, escape is possible. Inside it, escape is no longer possible. Once you cross this boundary, even light itself can't climb back out. It's not that the black hole is pulling harder. It's that space-time itself is shaped like a trap. And once you're inside, the idea of leaving stops being a real option. So what would happen if you fell toward a black hole? Gravity wouldn't pull on you evenly because gravity gets stronger the closer you are. Your feet would feel a stronger pull than your head. That difference stretches you out. At first, it might just be uncomfortable, but closer to the black hole, the difference becomes extreme. You'd be stretched out into this long, thin strand. This is a process called spaghettification. It sounds ridiculous, but it is real physics. And black holes distort more than just space around them. They distort time itself. Near a black hole, time itself runs slower. The stronger the gravity, the slower the clocks tick. To someone watching from far away, a person falling toward the event horizon would appear to slow down, almost freezing in place. Their light would redshift. They'd fade. Eventually, they would just completely disappear out of existence. But from the fallen person's perspective, their time still feels normal. And this isn't just some visual effect. It's the universe itself behaving differently under extreme gravity. So, if black holes don't suck, then why do they look so violent? The answer is, the danger usually isn't the black hole itself. It's everything around it. When gas and dust fall toward a black hole, they don't just drop straight in. They spin. They form a glowing ring of superheated plasma called an accretion disk. This disk can become hotter than stars. It can outshine entire galaxies. And some black holes even launch jets of energy from their poles. Jets so large, they stretch thousands of light years through space. But for a long time, even after Schwarzschild, scientists weren't sure black holes could truly exist. Even Einstein was skeptical. So for decades, black holes lived in mathematics, so to speak, not reality. Then in 1939, physicists Robert Oppenheimer and Hartland Schneider published a paper showing something chilling. A massive star running out of fuel. It can no longer support itself, and the collapse doesn't stop. Under enough mass, gravity wins completely. The star collapses past the event horizon, forming what we now recognize as a black hole. Meaning black holes weren't just possible, they were inevitable. The term black hole wasn't even widely used until the 1960s, popularized by physicist John Wheeler. Over time, astronomers found objects behaving exactly like black holes, invisible, massive things feeding on nearby matter. One of the most famous early candidates was Cygnus X1, identified in the late 1960s and studied heavily through the 1970s. But the final confirmation came a century after Schwarzschild. In 2019, the Event Horizon Telescope released the first image of a black hole, M87 star. Not the hole itself, but the shadow it casts on surrounding light. Then, in 2022, we saw the very black hole at the center of our own galaxy, Sagittarius A star. The equations were right all along. So, what is a black hole? It isn't a hole. It isn't a vacuum. It isn't a cosmic monster that hunts. A black hole is what happens when mass bends space-time so completely that escape stops being a possibility. A region of reality where the future points inward. Black holes are misunderstood because they're not objects, they're consequences.